Multi-stage amplifiers employ several individual single stages in their design, mainly to achieve gain or to achieve better impedance matching properties or a better frequency response characteristic. In these amplifiers, output of one stage is coupled to the input of the next stage through a circuit. This circuit may consist of resistors and capacitors, or it may consist of a transformer, or it may be simply a pair of wires. First one is called RC coupling, second one is called transformer coupling or inductive coupling, the third one is called DC or direct coupling. Each coupling circuit has its own merits and demerits. One point that has to be kept in mind is coupling network plays a significant role in shaping the frequency response characteristic of the total amplifier. Multi-stage amplifiers coupling schemes, part 1, series on semiconductor devices and circuits, lecture number 7.10. People go for multi-stage amplifiers when a single stage amplifier is unable to fulfill the requirements of an application that is on hand. The requirement may be more gain, more voltage gain, more current gain, or it may be different input impedance and different output impedances, or the requirement may be more bandwidth, more highest frequency of operation. To satisfy these requirements, one way out is going for multi-stage amplifier design. In multi-stage amplifier design, output of one stage is given as input to the next stage. Usually 4-5 stages are common in multi-stage amplifier design. Last stage output is connected to the load. First stage input terminals, they are connected to the source, and the signal given at the input terminals of the first stage, it passes through all the intermediate stages and reach the output stage and then to the load. Different schemes are there to connect output of one stage to the input of the next stage. These are called coupling schemes. In the present session, the focus is on different coupling schemes that are used in the design of multi-stage amplifiers, along with their advantages, disadvantages. Now we move to begin the core session. The circuitry used To connect the output of one stage of a multi-stage amplifier to the input of the next stage is called coupling method. There are three widely used methods for coupling. They are RC coupling or capacitor coupling. Second one is transformer coupling. This is also called inductor coupling. Last one is direct coupling. Notice coupling schemes. They are about interconnection between different stages of a multi-stage amplifier. What is multi-stage amplifier? It is an amplifier in which there are several stages, more than one stage. This connection between different stages, it is implemented either by RC coupling or transformer coupling or direct coupling. Then what is RC coupling? In RC coupling, the signal is coupled with a simple high-pass RC circuit. High-pass RC circuit is used. That's why it is called RC coupling. Note that it is a high-pass circuit. So it prevents lower frequencies reaching the next stage. Then what is a transformer coupling? Here, coupling of signal is affected by a transformer. As already mentioned, it is also called inductor coupling. Then what is direct coupling? Coupling the signal with the two conductors. It is called direct coupling. Notice in RC coupling, lower frequencies, DC also, it is prevented from reaching the other circuit, other stage. In transformer coupling, DC is prevented from reaching the next stage. In direct coupling, everything is permitted, 0 to high frequencies, to reach the next stage. Why RC coupling? Coupling is meant for providing connection between output of one stage to the input of next stage. So the answer to the question why RC coupling is to achieve signal coupling with the help of simple RC circuit. Why transformer coupling? To achieve maximum power transfer from one stage to the next stage. The output voltage of a transformer depends upon the turns ratio. By adjusting the turns ratio properly, it is possible to have high voltages, consequently high powers, coupled to the next stage. This facility exists only in transformer coupling. In other types of coupling, you don't find this feature. By direct coupling, it is the simplest possible. Notice RC coupling is simple, direct coupling is the simplest, transformer coupling is one which has the capacity to effect maximum power transfer from a previous stage to the next stage. Direct coupling is also least expensive. Now we undertake a detailed study of different coupling schemes. We begin the study with RC coupling. This is also known as capacitor coupling. It is already mentioned. It employs a high-pass RC network. This is also mentioned. A high-pass RC circuit, it appears like this. At low frequencies, capacitor is open circuit and nothing of the input reaches the output terminals. At high frequencies, capacitor is almost short, so almost total input reaches the output. It is used to interconnect individual stages of multi-stage amplifier to connect signal source to the input stage as well as output stage to its load. So capacitor coupling not only is used to interconnect stages of individual stages of multi-stage amplifier, it is also used to connect signal source to the amplifier and load to the output stage. It mainly finds application where it is required to block DC between one stage and its next stage, signal source and the first stage, last stage and its load. When DC is allowed to enter into the signal source, performance of the source gets deteriorated very soon. So some mechanism is required to prevent DC entering into the signal source. Usually it is done by implementing RC coupling between signal source and the first stage. Similarly, DC is not allowed to enter into the load. It becomes a drain on the source. Not only that, losses also goes up. To prevent DC entering into the load, again, some mechanism has to be implemented. RC coupling between load and the last stage. It gives prevention of DC entering into the load. Some more points regarding RC coupling. When used to interconnect the individual stages of amplifier, this coupling prevents the DC between the output of one stage and the input of the next stage, while allowing the AC signal current between the stages. So between one stage and another stage, signal is allowed to travel freely without any hindrance. Only DC is prevented. An advantage of this coupling scheme is it makes possible to have a DC bias voltage at the output of one stage that is different from that at the input to the next stage. So one can have different bias voltages for different stages in a multi-stage amplifier when one goes to RC coupling scheme. This RC coupling scheme gives that facility. It is associated with certain disadvantages also. What are they? The disadvantage of this method is that it affects the low frequency response of the amplifier. It does not allow low frequency components. Notice RC coupling prevents DC totally, completely from entering into the next stage, only DC. Whereas low frequency components of the signal, they are attenuated, but requirement is frequencies of the signal should not be affected, whether lower frequencies or higher frequencies or middle frequencies. No frequency of the signal should be affected by the coupling scheme. Ideal coupling scheme should not interfere with the signal frequencies. Lower frequencies attenuated means RC coupling is giving rise to some kind of distortion. So it does not allow low frequency components of the signal without much attenuation. To reduce this attenuation, large valued capacitors are required. Sometimes a compromise between practically large capacitor values and unreasonably lower cutoff frequencies is forced upon the designer. So lower frequency components of the signal are attenuated. Ultimately, this attenuation leads to distortion. RC coupling mainly finds application in discrete component amplifiers. This is hardly used in IC integrated circuits because it is difficult and uneconomical to fabricate capacitors on a chip. Here is shown two stages of a multi-stage amplifier. This is one stage. Nothing special here, just an BJT amplifier stage CE. Another stage. These two stages, they are connected through a capacitor. A capacitor is used for connection between the stages. So it is RC coupling between two stages. Now we move to another coupling scheme, transformer coupling scheme or inductor coupling scheme. This is another manner of coupling an AC signal from one stage to another while maintaining DC blockage. It uses a transformer with the output of one stage connected to primary and the input of next stage to its secondary. In this way, the AC signal is passed from one stage to other without DC current flowing between the two. So here also DC is prevented. The main difference between RC coupling and transformer coupling is, in both the cases, DC is prevented completely, totally from entering into the next stage from the previous stage. That is there, but in RC coupling scheme, it is simple. One capacitor is more than sufficient to implement RC coupling, but in a transformer coupling, a transformer is required. Transformer occupies more space than a capacitor. So it is voluminous. It is costly also, expensive. Of course, transformer coupling gives a facility affecting maximum signal power transfer from previous stage to the next stage. It's a great advantage. It's a great facility. Here is shown transformer coupling scheme. One stage, another stage. These two are connected through a transformer. Output of one stage is connected to the input of the next stage through a transformer. So transformer coupling. You can find transformer coupling here also at the output of the stage 2. Load, RL is load. The load is connected through a transformer by the second stage. This is also an example for transformer coupling. Here also transformer coupling. But when you come to the first stage, source is connected to the input of the first stage through a capacitor. This is an example for RC. So in the circuit, you can find one RC coupling, two transformer couplings. Some more points regarding transformer coupling. Primary advantages of this coupling scheme include low DC power dissipation and facility to design a turns ratio that results in maximum power transfer between stages. Dissipation, low power dissipation. Low dissipation means more efficiency, low wastage, low heat generation, low temperature rise. So several consequential advantages are there for low DC power dissipation. Another great advantage with the transformer coupling is, as already mentioned, maximum power transfer can be achieved between stages with the help of transformer coupling. Transformer coupling is also associated with disadvantages. What are they? Bulkiness. Space required is more for a transformer than a capacitor. So it is bulky. Transformer is expensive when compared to capacitor. Poor frequency response characteristic. This is also a disadvantage. It is found frequently that transformer inductance and interwinding capacitance limiting the useful bandwidth of the amplifiers. However, they are found highly suitable and useful for narrowband applications like RF amplifiers. So, problem with the transformer coupling is its narrow bandedness, lower bandwidth. Lower bandwidth limits its use with low frequency applications, but when it comes to RF applications, it is not a problem. So, transformer coupling is used at RF frequencies or in coupling stages of RF amplifiers, multi-stage amplifiers. With this, we come to an end to the session. To recollect, in this session, the importance of coupling schemes, different coupling schemes, and a detailed description of RC coupling scheme and transformer coupling scheme. All these things are touched upon, given on elaborate information. Regarding direct coupling, discussion is provided in the next session, part 2 on coupling schemes. Hope this session is useful to you. We meet again in another session on coupling schemes part 2 soon.